Hi, my name is Ana García Armada. I work at Universidad Carlos III de Madrid and I am the coordinator of TeamUp5G project. TeamUp5G stands for New Radio Access Network Techniques for 5G ultradense mobile networks. It is a European training network project started in January 2019. Its global objective is to set up an international doctoral training network for interdisciplinary and intersectoral research, knowledge sharing and training. We will team up a new generation of researchers and entrepreneurs ready to address complex engineering problems and innovation that are required to work both at university and industry. The TeamUp5G consortium includes academic and non-academic sectors and provides intersectoral and interdisciplinary training for the researchers in their areas of expertise, ranging from mobile communications to video applications, from research to industrialization, operation, entrepreneurship, intellectual property, and others. The network is coordinated by Universidad Carlos III de Madrid, and it comprises 15 early-stage researchers, 8 beneficiaries, and several partner organizations. Our main focus are small cells. Small cells are formed by low-power and reduced-sized wireless access points that operate in licensed spectrum and are operator-managed. Due to their low power transmission, small cells can potentially contribute to up to a 60% reduction of power consumption in the global communications infrastructure. The importance of the role of small cells has until now increased with each generation of mobile communications. With the continuous increase of data rates and the number of people using mobile communications, wireless connections are evolving towards 5G. The ultradense networks with small cells are critical to fulfill the user satisfaction. On the other hand, they are subject to challenging requirements for the evolution to 5G. They must be able to meet the requirements of very different types of applications. Nowadays, although there is a worldwide market of small cells, the network solutions have inherent technical limitations. Possibly, the most important challenge is the demand of increasing data rates per square kilometer. In the context of 5G, ultradense networks must be able to meet the requirements of two very different types of applications. On the one hand, in broadband mobile access, the capacity of the link is the most demanding factor. On the other hand, the ecosystem of the Internet of Things demands intermittent or always-on hyperconnectivity for machine-type communications and promises a hyperconnected smart world that can usher in many interesting opportunities and sectors of life. This leads to the explosion of small cells that will require new solutions to mitigate interference and optimize the network resources. In this context, TeamUp5G is addressing the following challenges to integrate and potentiate the role of ultradense networks in 5G new radio, grouped in these 3 blocks: interference management, waveforms and massive MIMO, dynamic spectrum management and optimization, and reduction of the energy consumption. Interference management is a must in ultradense small cell networks. It may also take advantage of the use of many antennas, what is called massive MIMO, with the drawback that it generally needs channel state information that may be not easy to obtain. With the aim to align the interference with no channel state information knowledge, a technique called blind interference alignment has been developed. However, the performance of this technique under channel variations and its implementation in multi-tier networks are open issues. Non-coherent schemes may be a way to avoid the channel state information bottleneck, but they need to evolve to efficiently multiplex an adequate number of users. The realistic practical implementation of massive MIMO still entails many research challenges. The use of the new millimetre-wave frequency bands for cellular systems combined with massive MIMO bring the advantage of compact antenna sizes that facilitate arrays with a very large number of antennas and very narrow beamforming. In turn, these frequency bands are subject to high propagation loss and lead to a high complexity of the transceivers. As an alternative, visible light communication systems are characterized by a reasonable complexity and cost. The use of blind interference alignment was also recently proposed for visible light communications based on a novel architecture of the receiver. In the process of defining the new 5G standards, the question arose about what the optimal waveform in ultradense networks is to combine with advanced MIMO and interference management. Providing a good balance between the different requirements of mobile broadband and IoT types of traffic remains a key question to solve. Moreover, actual research activities include the integration of radar and wireless communication technologies to improve spectrum management and pave the way for future IoT devices incorporating reflectometry-based sensing together with communication functionalities. Different types of waveforms have been considered, including orthogonal frequency division multiplexing and its variants. There is not a clear one-size-fits-all solution yet. In this regard, TeamUp5G is designing and evaluating new interference management and reduction and joint scheduling mechanisms to mitigate interference through cooperation. The design pre-coding techniques will require moderate or known exchange of information and will be used in combination with massive MIMO in a cellular environment with traditional lower radio frequency bands, millimeter wave, and also visible light communications. Advanced physical layer, new waveforms, and multi-packet reception techniques are under definition and particularly tailored for ultradense networks. Scheduling and resource allocation become essential components of wireless data systems because different users experience different fading conditions. Carrier aggregation adds a new dimension for the scheduling of the users in 5G and raises an optimization problem for the best use of the network resources. Then, unlicensed and licensed shared spectrum offer a set of possible advantages, which can potentially lead to greater spectral efficiency than exclusive access. Optimization of the access through the use of shared bands and cognitive radio allows the assignment of the underutilized spectrum resources where spectrum can be shared between license holders and secondary users in a dynamic spectrum allocation way. Dynamic spectrum sharing, license-assisted access, LAA, has been adopted by 3GPP, and LAA has adopted carrier aggregation as a mandatory function. In this context, small cells are the adequate candidate to accomplish the regulation in terms of limitation of the maximum transmitter power. TeamUp5G is working to improve aggregation across a range of spectrum. It considers aggregation also for the purpose of wireless backhaul and its joint optimization with the cellular access. New multiband schedulers with reduced implementation complexity that optimize both fairness and service level parameters in a multi-service traffic scenario will be developed in the implementation of carrier aggregation in 5G heterogeneous networks environments with small cells, within broader macro cells, as well as in the cell-free scenarios. Today, mobile network energy consumption is very significant and requires our attention. The good news is that the spatial temporal traffic characteristics in mobile networks are continuously changing, and significant efficiency savings may be achieved by dynamically adapting the network resource provisioning, including energy, to changes in traffic characteristics. Moreover, in cases where mixtures of macro and small cells are deployed, the potential of improving becomes even higher. On the other hand, challenging traffic for emerging 5G applications, such as machine-to-machine, worsens the situation and requires different approaches to energy reduction due to solutions such as multi-connectivity. Further work is needed on mechanisms for energy consumption reduction in the context of energy challenge scenarios, such as IoT, particularly considering the increased duration of batteries. The project proposes energy-aware MAC protocols with cognitive radio capabilities and optimizations in these protocols. Energy awareness will be studied for long-range radio technologies. Because of the different nature of the underlying physical layer, the reuse of current protocols is not direct. Joint optimization techniques will be designed to provision machine-to-machine traffic, serving as backhaul of the network of sensors along with their own cellular traffic. TeamUp5G activities will focus on the following use cases: emergency drone, a drone with capacity to transmit video images and other information about the environment in real time, as well as assuring the communication between the decision centers and crews for the general population. Predictive maintenance in manufacturing within the context of Industry 4.0, jam traveling, where users would like to experience a 360-degree view from a flying drone using immersive technology, multiplayer game and live events using virtual reality, and safe family traveling, where high-speed vehicular communications are considered as an important challenge. TeamUp5G started recently. Here are some of our initial results. We are proposing new scheduling algorithms for interference management, advances in non-coherent communications, advances on waveforms and separation algorithms for joint use in radar and communications, radio resource management, and the application of 5G ultradense networks for the distributed implementation of immersive media rendering. Thank you very much for your attention.